Welcome back to the active class. In our last video, we discovered that two figures are congruent if they have the same shape and size. If you missed that, check the link in the description. It's a must watch. In that video, we overlapped one triangle over another to check for congruency. But what if we can't physically move them? What if we just see two triangles on paper? How do we prove they are exactly the same? That's where mathematicians step in. They have discovered some powerful shortcuts, rules that help us prove triangle congruence quickly and without confusion. Let's explore them. Our first rule is side, 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 or yes, yes, yes axiom. The term axiom means a statement that is accepted as true without proof. It is considered as self-evident and it doesn't need further proof. Please have a look over these two triangles. They are congruent by yes, yes, yes axiom. Can you guess what does yes, yes, yes or side, side, side axiom means? Great. If all three sides of one triangle are equal in length to the corresponding three sides of another triangle, the triangles are congruent by yes, yes, yes rule. Yeah, the equal corresponding sides here in these two triangles are indicated by the equal lines like AB and YZ. They are indicated as equal with double lines. Likewise, AC and XY, they are indicated with single lines. And the third sides are indicated with three lines. Here, AB is equal to YZ. It's a pair of corresponding sides. AC equals to XY, another pair of equal sides. And BC equals to XZ, the third pair of equal sides. Boom! Triangle ABC is congruent to triangle XYZ by yes, yes, yes axiom. Whenever we see two triangles in this form, then we can directly call them congruent by yes, yes, yes axiom. Try this. Draw any triangle, then use your ruler and compass to make another with the same three sides length. Guess what? You just created two congruent triangles by yes, yes, yes axiom. Trust me, they are equal in shape and size. See? Next up is the side angle side rule or SAS axiom. Let's have a look over these two triangles. These triangles are congruent by SAS axiom. If so, can you tell what does this axiom state? Great. If two sides and the included angle of one triangle are equal to the corresponding two sides and the included angle of another triangle, the triangles are congruent. Can you tell me the two equal sides in this triangle? Great. The first side is AB and YZ. Side AB is equals to side YZ. Likewise, the angle BAC is equals to angle XYZ. BAC is this angle and XYZ is this one. Finally, side AC equals to side XY. Make sure that This term included angle. The angle should always be formed by the two equal sides. If these three properties are there between any two triangles, then they are congruent. Here in this case, triangle ABC is congruent to triangle XYZ. This is by SAS axiom. That means side angle side axiom. Grab a ruler and draw any triangle. Now, using your tools, create another triangle with two sides and the included angle matching your original one. Do they look exactly alike? In these two triangles, side XZ is equals to side AV. Likewise, side XY is equal to side BC, and the angle between these two sides are also equal. Means they are congruent by SAS axiom. If these triangles are congruent, then of course their shape and size will be exactly the same. See? They are exactly the same. It's time for angle side angle axiom, that is ASA axiom. Have a look over these two triangles. They are congruent by angle side angle axiom. If so, can you guess what does this axiom state? Very good. If two angles and the included side of one triangle are equal to the corresponding two angles and the included side of another triangle, then the two triangles are congruent by ASA axiom. Remember, the side should be included by the two angles. Here, the side BC, which is indicated by the blue line, is included by angle B and angle C in the first triangle. Likewise, the same side is included by angle Z and angle X in the second triangle. In ASA axiom, A comes first. That means a pair of equal corresponding angle. Can you tell me a pair of equal corresponding angle? Very good. Angle ACV and angle YXZ are a pair of equal corresponding angle. Then comes side. Can you tell me a pair of equal corresponding sides? Very good. BC and XZ are the equal corresponding sides. Finally, can you tell me a pair of equal corresponding angles that include side BC and XZ? Very good. Angle ABC and angle XZY are the second pair of equal corresponding angles. If these three conditions are satisfied between any two triangles, then the triangles are congruent by ASA axiom. Grab a ruler and protractor and draw a triangle. On a separate sheet, construct another triangle with equal corresponding two angles and included side by using your ruler, pencil, and compass. Cut them out and stack them up. Do they overlap perfectly? If yes, congratulations,
You have just proved ASA axiom.
Next up, angle-angle-side axiom or AAS axiom. In this axiom, if two angles and a non-included side of one triangle are equal to the corresponding two angles and non-included side of another triangle, then the two triangles are congruent by AAS axiom. Here, the side is non-included one. In previous axiom, ASA axiom, the side was included, but here the side is non-included one. So in ASA axiom, there comes a pair of equal angle first. So please tell me can you please tell me the pair of equal angles? Very good. Angle ACV and angle XGY are the first pair of equal angles. Can you tell me the second pair of equal angles? Great. Angle BAC and angle YXZ are second pair of equal angle. So we are done with A and A. Now you need to have a pair of equal sides which is non-included by the angles. Can you tell me that side over here? Great. AV equals XY. It's a pair of equal sides. Boom. Triangle ABC is congruent to triangle XYZ by angle-angle-side axiom. If you have any two triangles and they satisfy these three properties, then we call them congruent triangle by angle-angle-side axiom.
Proof of AAS works just like ASA. If two angles are equal, the third angle must be equal too. So follow the same steps as before. Construct two triangles with the same two angles and a non-included side. Cut them out and stack them up. Do they match up perfectly? Yes, that's AAS in action.
Finally, the right-angle-hypotenuse-side axiom, which is RHS axiom. Let's have a look over these two right-angle triangles. These two triangles are congruent by RHS axiom. As per RHS axiom, if the hypotenuse and one side of a right-angle triangle are equal to the hypotenuse and one corresponding side of another right-angle triangle, the two triangles are congruent by RHS or HS axiom. This axiom is applicable only in case of right-angle triangles. Here, both the triangles are right-angled. In RHS axiom, both the triangles should be right-angled, means 90 degree. So can you tell me the name of 90-degree angles in both the triangle?
Very good. Angle ACV and angle XGY are equal to 90 degree.
These angles are right angles. After R, there comes H. H means hypotenuse, which is the side just opposite to the 90-degree angles. We call these sides hypotenuse. And can you see the hypotenuse equal in both the figures? Yes, they are equal. AB is equal to XY. Both are equal and both are hypotenuse. And after H, there comes, yes, a pair of equal corresponding sides. And can you spot those two sides? Very good. BC and YG are the equal corresponding sides. That means all three properties, that is right angle, hypotenuse, and side, are satisfied by these two triangles. Therefore, triangle ABC is congruent to triangle XYZ by RHS axiom.
Time to test it yourself. Draw a right angle triangle using your ruler and protractor. Now try constructing another triangle with the same hypotenuse and side. Do they match? If yes, congratulations, you have just proved RHS.
Fantastic work. Today, we uncovered 5 powerful triangle congruence rules, which are yes, 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 ASA, AAS, and RHS. To prove two triangles are congruent geometrically, we identify one of the triangle congruence rules that applies to the given triangles. By logically demonstrating that the corresponding sides and angles match according to one of these axioms, we can confidently conclude that the triangles are congruent. What next? In the next video, we will dive into the step-by-step geometric proofs using these rules. So stay tuned. Challenge for you. Look around. Can you spot two real-life triangles that match one of these rules? Maybe on a window frame, shelf, or even a folded napkin. Drop your coolest find in the comments below.